So I wanted to show you guys the tetrahedral geometry that we just talked about in the last video with the FET. So this would be AB4 and then no E. So this would be like the first example. It's a geometry is tetrahedral because there's 4 areas of bonding or lone pairs, but in this case they're all bonding. And then so this part here is the tetrahedral geometry, and then this is a tetrahedral shape. Another tetrahedral geometry would be AB3E. So this is what a trig pyramidal shape would look like. It's a geometry of tetrahedral because it still has the 4 total areas. And then this, when we add the 2 lone pairs, this would be also tetrahedral geometry because we have 4 areas, but the shape is bent. And then last example that we just went over would be if, I think I can do this on here, we have a linear molecular shape, but it's still tetrahedral geometry because there's these 3 lone pairs and then 1 bond. So now we're going to talk about SP2 hybridization. Previously that was SP3. So SP2 hybridization is going to be, where we have the hybridizing going on between the S and the P to make 3 equal energy hybrid orbitals. So our first example is going to be when we have, and we call this, by the way, trig planar geometry. But this is also, the first example is actually going to end up being a trig planar shape, molecular shape. So we would have our central atom with 3 going around. The difference between this and the SP3 hybridization is that there's only a total of 3 bonding areas for our geometry. And in this case, these 3 are actually bonded and then no lone pair on top. So 3 bonds, 0 lone pairs, we would call this AB3. Boron is an exception to the octet rule. So having just 6 valence electrons is okay with boron. So the next trig planar geometry is when you would have a central atom, 2 bonds, and then a lone pair of electrons. So an example over here is, nitrogen would be our central atom. There's the lone pair. The 2 bonds, now notice that one of these is a double. The double is still considered 1 bonding area. So when we do the ABE, it's still just 2 bonds, not 3. 2 bonding areas, and then the 1 lone pair, so we would call that AB2E1. I don't know that you necessarily need the 1, but AB2E would be fine also. And then lastly, for the trig planar geometries, we could have 2 lone pair electrons, 1 bond, still adds up to 3. These are always going to add to 3 when you're in the SP2 hybridization. For the SP3, they always added to 4. So here our ABE would be AB and then E2 for the 2 lone pairs. I can show that to you on the FET. So the first example, if we look here, we have the trig planar molecular shape. Notice it's planar, it's flat. Different than the trig pyramidal, where that lone pair on top caused it to bend down. The next one that I showed you was, I think it was nitrogen and triple bonded and then single bonded, I think. So maybe not. I'm going to just skip that for now. Sorry. I want to go and I want to just talk to you guys now about the last type of hybridization is SP. So our total bonds and lone pairs will add up to 2 now. Sometimes you'll have beryllium, which is an exception to the octet rule, with just 2 bonds, so it ends up with 4 total valence electrons. It's also possible to have carbon, this example here, where carbon would be the central atom, has no lone pairs, and it has 2 bonding areas. So remember that triple bond just counts as 1.